Hello everyone, let's take a look at our next problem. An equilateral triangle is inscribed in the ellipse whose equation is x squared plus 4y squared equals 4. One vertex of the triangle is 0, 1, when altitude is contained in the y-axis, and the length of each side is the square root of m over n, where m and n are relatively prime positive integers. Find m plus n. Okay, first thing we're going to do here certainly is sketch a diagram. So we should be able to sketch the ellipse easily. We're given one vertex of the triangle. Not going to lie, when it comes to these triangle problems and stuff like that, some of the terminology I completely forget. I don't remember what an altitude is. If I had to guess, that's where you drop from a vertex to an opposite side and intersect at a right angle. I'm going to go with that for now. Okay, so that altitude is contained in the y-axis, and we're given that it's an equilateral triangle, so we should be able to figure out from all of that where the other points are. All right, I'm just going to start sketching a diagram and see how much of this information we can make use of. Okay, so given that we have one of the vertices at the point 0, 1 and an altitude contained in the y-axis, the other two vertices should be symmetric around the y-axis like this. And so it should be, I don't want to say easy, but I mean, I think the approach that I'm going to take here is just trying to find what these 2 points are. And like I said, they're going to be symmetric around the y-axis. So the information that we have here that we're going to use is the fact that these points lie on the ellipse, and we're given an equation of the ellipse. As well, we know that it's an equilateral triangle, so these angles are 60 degrees. So maybe what I'll do is I'll just write down the equation for a line that goes through the point 0, 1 and has the appropriate slope, whatever that slope happens to be. And then we'll find the intersection point of that line on the ellipse down here. That'll tell us what this point is, and then we can compute the side length. Okay, so I think I found the coordinates of this point that I'm looking for. So a couple things that I kind of hope that I did right here. So to find the slope of this line that I was looking for, I drew the 30, 60, 90 right triangle. I made this mistake in a previous problem. I'm pretty sure that I've got the correct side lengths of this triangle now. So then tan of pi over 3 should be root 3. So the slope of this line will be negative root 3. Does that make sense? I'm going to go with it. Okay. So I've got this. I've got the equation for that line. I simply make this substitution for y in terms of x into the equation of the ellipse that we're given. After some simplification, I end up with a value of x, 8 root 3 over 13, and I end up with a value of y, which is negative 11 over 13. So the fact that y comes out to be negative makes sense, right? This point is clearly below the x-axis. And the magnitude of this point, let me write down the coordinates of this point. 8 root 3 over 13, comma, negative 11 over 13. And the magnitude of the y-coordinate is less than 1, which makes sense because we know that this point is at 0, -1, and this point is closer, it's further up. So the y value should be closer to 0. Okay, so I just need the formula for the side length now. The side length squared is going to be, well, the distance between the 2 points, right? So the, whatever, I'll just write it out like this, delta x squared plus delta y squared. Okay, so I've solved for the side length, or at least I've got the side length squared here. In terms of reducing this to, so that the numerator and denominator are relatively prime, this is 13 squared. So all I've got to do is check whether 76 is divisible by 13. I don't know of any tests for this. I kind of suspect it's not going to be, but I'm just going to check really quickly to see what we get. Yeah, so this is not divisible by 13, so there's no reduction we can do here. So the side length is 768 over 169, all under square root. And this is, you know, we're told that the side length is given as the square root of m over n. So now m plus n, I get 937 as the answer here. There's a few places where I could have gone wrong, I suppose. A lot of arithmetic went into this, and you know, any little mistake in the arithmetic is going to carry through. I think that my approach, the way that I set up the geometry, well, sketching the figure is one thing, but then recognizing that we can just put an equation for this line down and find this point of intersection and then compute directly the distance. I think that's a pretty good, straightforward approach. Maybe there's a cleaner, more direct or elegant way of doing this, but that's the first thing that came to my mind. Fairly confident in this, except for the possibility of mistakes in the arithmetic, but if I find a mistake or if I have any more comments, I'll put them in the description. Otherwise, thanks for watching.